When figuring out your KEQ expressions and whether your equilibrium is going to favor reactants or products or both, it is really, really, really important to pay attention to the states of matter because your KEQ expressions are going to be different if you have a homogeneous system at equilibrium or a heterogeneous system at equilibrium. A homogeneous means that all of the reactants and all the products are in the same physical state. So you'll see this with everybody being gases and everything is all hunky-dory and you can react and plug in your values just fine. But if you have a different system, if you have different, more than one physical state, like liquids and gases or solids turning to aqueous, you have to approach things a little bit differently. Okay, so let's talk about a heterogeneous equilibrium. All right, so bromine in real life is going to be a liquid at room temperature. All right, so that's why we colored them in blue on the periodic table. If you have bromine in here, it is going to vaporize and it is going to become bromine gas. Okay, and you have a little stopper on the top of your container here. And what you'll see is that the bromine will vaporize and then eventually there will become such a pressure up here that the gas will start to condense until you reach this system at equilibrium and it looks like it is stopped. So when it is stopped, it actually is at our equilibrium where the rates of the two things are going to be the same. Okay? Does it matter how much liquid is in your container? Or will there just be a certain amount of bromine gas? The reason is that we don't count any of these pure substances is because no, it doesn't matter. It is not dependent on how much is in there. You would have the same amount of gas whether it was this much or whether it was this much or whether it was this much. Gases are mainly empty space, so it doesn't affect it. All right. And that was always a tough concept for me to understand as well. All right. So it said the concentration of gases for bromine will be the same. Okay. Same. No matter how much liquid bromine you start with. Changing the liquid bromine does not change the amount of gas of the bromine. Okay. So that means that you need to star, circle, highlight this slide right here. Okay, this is the one that is really important. Okay, chemists will omit or not put in the KEQ, pure liquids and pure solids, from the expression. They only do things that they can measure in concentrations of molarity. You can figure out the moles of gas and you can figure out the moles of your aqueous dissolved substances for your expression. So you're only going to pay attention to these. So what do you do if you see a liquid or a solid? That means you don't write it. Okay, so what is the KEQ expression for CaCO3, which is our chalk, okay, solid chalk, decomposing into CaO, which is a solid, and CO2 gas? Remember, that's why we had that upward arrow. Okay, well, the concentration of the products raised to their coefficients over the concentration of their reactants raised to theirs. So let's plug it in, plug it in. Okay, so we have CaO solid, so that's just one. And we have our concentration of CO2 as our products. And then our reactants is a solid, so that's just one. So the KEQ value for this is just CO2. That's it. Okay, it does not matter how much CaCO3 you have and how much CaCO you have. It only depends on your gas. Okay, similarly, you'll see something like that happen with our dissolved substances. BAF2, okay, which is a solid, breaks up into Ba2 plus and 2F minus. Both of these are aqueous. So the KQ expression is Ba2 plus times the concentration of F minus squared, and you see nothing about the BAF2 because it is a solid. Oops. All right, so let's do a couple more examples to kind of help you out here. All right, write the KEQ expressions for each of the following. All right, so we have KEQ equal to concentration of products raised to their coefficients over the concentration of reactants raised to their coefficients. All right, so this is a solid, water is a gas, CO is a gas, H2 is a gas. So if it's a solid carbon, we don't count it. So we simply do the concentration of CO times the concentration of H2. They're both ones, so we leave them like that. And that's going to be over the concentration of H2O gas. What is the KEQ for this? Well, this is aqueous, this is a gas, this is a liquid. Liquid is a pure substance, so we're not going to count that. It's just the concentration of CO2 over the concentration of H2CO3, or carbonic acid. Voila, those are our substances. Okay, so you see, because um, we don't count our solids and our liquids, they are not in our KEQ expressions. No pure substances. All right, so lastly, our turn. Let's try some more. Okay, we'll write the KEQ expressions for these two reactions. Again, products raised to their coefficients over the reactants raised to their coefficients, and cancel out any solids that you see. So this would be the concentration of CO over the concentration of CO2. And for the second example, PbCl2 aqueous makes Pb2 plus aqueous and 2Cl minus aqueous. KEQ is going to be the concentration of Pb2 plus times the concentration of Cl minus squared over the concentration of PbCl2. You count at that time because it is an aqueous substance. Okay, if it were not aqueous, you would not count it. Okay, so those are our KEQs for our heterogeneous substances.